Ionic compounds versus molecular compounds have different boiling points. To boil something, you have to break the bonds. So that means the stronger the bonds are, the higher you have to raise the boiling point. If something has weak bonds, it will boil at a low temperature. If it has strong bonds, it will boil at a high temperature. Because when we boil something, we're trying to break those bonds. Well, ionic bonds are basically the strongest of the ones we'll study. And molecular bonds are significantly weaker for the most part. So if strong bonds are hard to boil, we need a higher temperature. Higher temperature, more energy to break those bonds. Weaker bonds, we need a lower temperature. So generally in the book, we'll talk about molecular bonds breaking, or they might say what happens at 40 degrees Celsius. That's a relatively cool temperature. That's something we experience just on a hot day. So if something's boiling at 40 degrees Celsius, it's got to be molecular because it has weak bonds. If something's boiling at 700 degrees Celsius, well, then that has pretty strong bonds, and we can assume it's an ionic bond, an ionic compound. Remember, you need to be able to identify an ionic and a molecular. And we do that, of course, because an ionic compound will be composed of a metal atom in the first part and a nonmetal in the second part. So, for instance, sodium chloride, metal, nonmetal, that tells you it's an ionic bond, which means strong bonds, which melt at higher or boil at higher temperatures. Whereas a molecular is going to be something with two nonmetals. And so if we have something like, carbon dioxide. Okay, carbon is considered a nonmetal, oxygen is a nonmetal, therefore we have a molecule, it's going to have weaker attractions, it's going to boil at a lower temperature. And of course, remember, how do we know a metal from a nonmetal? Well, on our periodic table, there's a little jagged line here. These guys are all metals, and these guys are all nonmetals.